Yo, at home, here, where are we going? Where are we going, guys? Sophia?
29.
29, everybody. Okay, 29. Everyone sees my arrows, my parallel lines. Okay, let me highlight those so we can stay focused on them. Here, and you can even extend them if you want. Those are my parallel lines. Making the other two lines I didn't highlight, those are called what? The line that goes through the two parallel lines. We call that a 20. We call that, Radhika, what do we call that line that cuts through the two parallel lines?
Transversal.
Transversal. You got two of them in the diagram. Please only look at one at a time. Here's what I mean. Let's look at just this transversal right here. So now, the 120 and the x, what type of angles are they? Where are they inside? Are they outside? Are they on the same side of the transversal or opposite sides? What type of angles are 120 and x? Name them. Give them a name, please. Here we go. 5. What do you got, Hayden?
They're the same side interior.
Same side interior. What do I know about them?
The supplementary.
That helps me write the equation to know that they add up to 180. Boom, done. Everybody's good. Questions? So x came out to be 60 here, right? 60? Okay, so you got x is 60. Now you're going to look at probably these two up here. 3y plus 40 and 3x minus 70. Right next to each other. I don't need parallel lines for this. What do I call those angles that are adjacent to each other and form that straight line? Going back to Unit 1. Unit 1. Owen. These are what type of angles here?
Linear pairs.
Linear pairs, so they're supplementary. But I don't want to add them up and set them equal to 180. Why not? That's probably a bad move for me. Why? Go ahead.
Because one of them's got the y variable and one of them's got the
If I set up the equation, I'm going to be solving an equation that's got y and x. That's ridiculous. So I don't want to do that. But didn't I just find x is 60? Plug it in. Find that angle. And then say, okay, 180 minus it is going to give you equal to 3y plus 40. See how I'm approaching that one. Okay, see how I'm going to approach that. Okay, another way you could have done it, I don't know if anybody did it this way. Let me clear out everything. Nope, never mind. You can't do it that way because those lines aren't parallel. Sorry. So you plug 60 in for x. What is that, 180? That's 110 right here. So that angle's got to be 70. So I could say 3y plus 40 equals 70, and I'm on my way to solve for y. We all good? Again, parallel lines, two transversals, but only look at one at a time and figure out what the relationship is. Next, let's keep this going. Next up, Caroline, go. 28. All right, very similar to 29. So
Wasn't it 39? Do we have to do it? Not 29? That's what it says on the sheet. You have to do both.
both.
Yeah. Oh, both.
Okay, 28. Very similar problem. Here you go. Here are my parallel lines again. With two transversals. One on the left, one on the right. So let's look at the one on the left first. Here's the one on the left. What type of angles are 5y and the 120 now? 5y and the 120. Look at where they are. Inside, outside. Same side or opposite the transversal. What am I going to call 5y and 120 here? Here we go. 15. Will, going back to you. What type of angles are 5y and the 120?
Same side interior.
What do you know about them? Congruent or supplementary?
Supplementary.
Boom. 5y plus 120 has got to be equal to 180. That's where I got that from. Let's go on the other side. 2x and the 108. Woo! 2x and the 108. What type of angles are those now? Well, they're still inside, right? Even though the 108 is outside the diagram, the 108 is still inside the parallel lines. Everyone agree? And are they on the same side or opposite sides of the transversal? Good. Same side or opposite side of my transversal here? Opposite. So what am I put the two together here. I don't have opposite interior angles. What do I have? Alternate interior. They are congruent. Boom. Hey, it's power. It's power knowing what those angles are and what they do. All right. Next, let's go. I'm waiting for it. I'm waiting for it. Which one?
39.
39. Here we go. Okay, right now what you could do, You could say, all right, that's 105. And again, I'm going to erase all this in a second. Why can I say that's 105? What gives me the right to say that angle's also 105? Here you go. 5. Hayden, why is that angle 105?
Because they're vertical.
They're vertical. Done. Okay. I can also say this angle is 75. Why? Why can I say that angle's 75? 4. Here you go. Gideon, why can I say that angle's 75?
Because they're supplementary.
They're a linear pair. They're supplementary. That great. And I could do the same thing down here with 125. But you know where that's going to get me? Nowhere to find x. There's no way you can use any of those angles to get to x. So that is why in the video, I showed you guys that you want to draw in what's called an extra line, an auxiliary line. Okay? Because right now, everyone see my two parallel lines. Why is that not a transversal? Why is this part here not a transversal? It doesn't go through both of them. Hey, same thing, right? That bad boy's not a transversal. Everyone agrees it's got to go through both. So you want to make an auxiliary line, and preferably that goes through the middle, and that's parallel to all of them. So now watch, ready? Here we go. Let's take those two. Now is this line a transversal right here? Yeah. So now you're going to look for alternate interior, corresponding, any of the good stuff here. All right, any of the good stuff. Let me go back. I said this was 75 right there because they're supplementary. What type of angle is this 75 and this one right there? What type of angles am I working with right there? 26. Emma, what type of angles are the 75 and the other one I just marked with the brown arc?
Corresponding.
And what do you know about them, Emma?
They're congruent.
Okay, there we go. So that's got to be 75. It does not bisect the angle. It does not bisect the angle, guys at home. All right, it does not. So what I need to do is go to the other side of the diagram. Everyone see my two parallel lines now, and now it's a transversal. Same thing. That's 125, 55. What type of angle are the 55 and this one right here? Here we go. Woo, 19. Sean, what type of angle is the 55 and the one I marked in blue here? Corresponding. They're congruent. And now what can I do with those two angles to find angle X? There we go. And I just want to make sure we get I drive this point across. That's not the only way to do this. You know, I said that was 105 right here, remember, because they're vertical. And then you could have said those two right here are same side interior, so they're supplementary. A lot of different ways I could have got to it. Okay, but does everyone see why this helps drawing in the auxiliary line? Because now this is a transversal, and so is this. Okay? At the beginning, when I wiped the slate clean and got rid of that line, I didn't have any transversals. We okay there? Because you're going to see that on the quiz too next week, where you have to draw an auxiliary line to help you out with the problem. Okay? Sophia?
45.
All right, let's just get it done. Let's rip the Band-Aid off of this. Here we go. Find X and Y. I know it said challenge, and I warned you guys that some factoring was going to happen here. Quick question. Here we go, 23. Luke, here's my question, Luke. What's the relationship between those two angles, X and 8y minus 15? They're what? Supplementary. They're linear pairs. Do I want to add them and set them equal to 180, though? Why do I not want to add them and set them equal to 180? What's going to happen, guys? Oh, go ahead, Luke. Go ahead.
There's an X and a Y.
Yeah, we already talked about that. Get out of here. So can I set up an equation with just Y or just X? Absolutely. Let me go to somebody now. What type of angles are those two that just use Y? Let's roll. 14. Here you go. Ellie, what type of angles am I working with?
Alternate interior.
Alternate interior. Congruent or supplementary? Congruent. So here's your equation, guys. Y squared equals 8y minus 15. And I hate to break the bad news to you guys. My geometry is done. That's what geometry led you to right there. Guess what's taken over now? Algebra 1 last year. Yep, that's what's taking over now. Everyone see a squared, and I learned my lesson the hard way in my first period class because I heard crickets. I know maybe you guys did this in the spring when you were fully remote. I have no idea. Everyone see the squared? Squared, 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 factor, factor, factor. If you see the squared. You are not allowed to factor this yet. Anybody know why? No factoring yet. Not allowed. Why, Omni?
Because they're not all on the same side.
Got to be equal to 0. One side has to be equal to 0 before you start any type of factor. Now, I know it's pretty easy probably to move the y squared over. I don't know how you guys feel. I always love the square term to be positive, though. That's where I feel more comfortable, warm inside, get that good feeling. So instead, I'm going to move the 8y into 15 over. So here's what I end up getting. Y squared minus 8y and plus 15 when I move everything over to the left side. Everyone with me so far? We're all good? Oh boy, this is when my heart, the little heart that I do have, and when the ice does melt off, just sank first period. Just sank when I asked how to factor that. Oh boy. And I just got awkward stares at me. Awkward stares. You remember what game you have? Not really game, but you have to think about two numbers that do what? How's the 15 come into play? Oh boy. Anthony, help me.
When the two last numbers are multiplied together.
You need two numbers that multiply to positive 15, but at the same time,
Add to -8.
add to -8. That is this factoring method here. Multiply to 15, add to -8. There's only very few numbers that multiply to 15, right, guys? 1 and 15 and 3 and 5. How do I make them add to -8? Make them both negative. All right, there's the factoring part. And by the way, I'm not trying to scare you. I'm trying to be honest with you. I do not shy away from factoring at all in this course. Whether it be quiz, tests, homework, that is something we do all year long because you go back to it right away next year in Algebra 2. All right, so I do not shy away from factoring. All right, from here, you guys remember setting it equal to 0 and solving? So you have two y values here, correct? Two y values, y equals 3 and y equals 5. That's why 3 and 5 were both answers on the answer key. Everyone good so far there? There's a problem though. Your diagram had also what variable? X, right? Okay, so how do I find the x values? All right, let's start with y equals 3. Everyone ready? Y equals 3. I'm going to plug it in for y squared. What is that angle now? If I take y equals 3 and plug it in for y squared, 15 will. What's my angle up there for y squared now?
9 degrees.
Everyone agrees, 9 degrees? So what's x have to be then? What's that? What do we call those two angles? I'm going to grill you guys these first couple days. It's brutal. Here we go. Zach, what do I call those two angles? The y squared and the x. They're what type of angles?
Same side interior.
So supplementary or congruent?
Supplementary.
Okay, so you guys understand where the 171 comes from now, right? That's 171 to make them supplementary. So x equals 171. But there was another value y could be, correct? All right, so let's go back. Y could have been 5. So now what's my y squared angle? If y is 5, what's my y squared angle? Here you go. Emily, what's my y squared angle?
24.
25, yep. And I'm not going to ask again. Zach just told us those angles are supplementary. So 180 minus 25. Does everybody see where 155 comes in now? All right. Questions there? Again, I'm just warning you guys. No threats, no trying to scare people. It's just I do not shy away from factoring in this course. Any other questions that we need to go over? Anything else? You guys at home, clean up what you got to clean up. If you have time to submit. We got 1 o'clock today, submission deadline. You guys in here, let's see what you got. Hopefully you're going to show me a lot of work here. Everybody is, nope. Okay, good, good. Same with fly here, guys. Just roll. Good, good work, Quincy, good work. Show more work, guys. Gotta show more work, guys. Guys, please show more work. Yeah, I'm not gonna accept it. Show more work. Good. Got one here. Good job. Show more work. Nice job. Okay. Notes out. Day 2. Here it is. Welcome back. Proofs. You got a day off. They're back. Excuse me. Nope. Sorry. Wrong one. Up here. All right. I just have to modify one of the assignments to add somebody in. Okay, as I'm just finishing up here, I'm just letting you guys know that that sheet that you kept that had all the theorems on it, you don't get that for any other test or quiz anymore. That's it. That was a one-time deal for Unit 2. All right, that was a one-time deal, and that was it. All right, and as you can see, the board is bare now, so you are on your own for those theorems. And those theorems, unfortunately, aren't going anywhere. All we're doing now is making the proofs longer. Okay? Your 2 steps now are becoming 4, 5, 6 steps. All right? Questions? All right, before I start, I don't know why I have to remind honors kids with this, but let's get on the camera, everybody. Let's go. Because then I hear, oh, you didn't go over this. Well, you should have been on the camera watching. How about that? All right, let's roll, guys. Let's dive right into it. I do not want to throw you into the fire right away. So as you can see in this proof, I provided the statements. You just need to help me with the reasons. A is parallel to B. Mark it. Here we go. Let's mark it. A is parallel to B. And C is parallel to D. Now, you can do 2 arrows if you want. It's going to kill me here. All right, back in business. Here we go. You guys can do 2 arrows, or you can do double arrows if you want. That's up to you to signify what lines are parallel. Okay, we all good? That was it. That's all I gave you guys. The lines are parallel. And we need to get down to why 1 and 3 are congruent. So everyone take a look at 1 and 3 right now. Are those alternate interior?
Yeah. Wait, no.
No. Are they corresponding? No, I don't. Corresponding moves up and down, left and right. They don't move diagonally. Are they same side interior? No. What am I trying to get at? 1 and 3 have no relationship. None. Can we all agree upon that? They're not any special type of angle. So that's why this is a 4-step proof and not a 2-step proof, because they don't have a relationship. So how do I get them congruent? Well, I'm suggesting in number 2 that 3 and 2 are supplementary. I need to know from you guys why. That's a true fact. I wouldn't have wrote it down. 3's supplementary to 2. Look at the diagram. 3 and 2 are what type of angles? Look back in your notes if you need to. No shame in that. And I just totally lost my spot here. Here's 21. There we go. Zach, what type of angles are 2 and 3?
Same side interior.
Same side interior. What do you know about them?
They're supplementary.
Right? They're same side interior, so they should have been supplementary. So what's my reason? I had you guys write this down a bunch while you're watching the video. What did I give you? What type of lines? So you're going to start off by saying parallel lines And then you're going to use this arrow pointing to the right, which means implies. So if you have parallel lines, that means what type of angles are 2 and 3? Same side, name them. So same side interior. Angles, what do you know about them? Same side interior angles are supplementary. Okay? Yes, Almy.
Can you still write out the word imply, or would you prefer for us to use the
I don't care. Yep. The only thing I care about is if you start using your own abbreviations, that's what I care about. But anything I abbreviate, you're allowed to. So everyone all good? All right. Step 3, I'm saying 1 and 2 are supplementary now. 1 and 2. Why? Why are 1 and 2 also supplementary? Zach, I heard from you already. I'm going to hear from somebody else yet here. Here we go. Ellie, why are 1 and 2 supplementary?
They're linear pairs.
They are? Linear pair would be if 2 was right there, right? Or if 1 was right there. They would be a linear pair. They're not next to each other. They don't share a vertex anywhere. But 1 and 2, inside or outside?
Inside.
Same side or alternate sides?
Same inside.
So what do we call them?
Same side interior.
And what do you know about them?
Um,
Congruent or supplementary?
supplement.
Okay, so same reason. Same reason as number 2, right? They're same side interiors. So if some of you are asking right now, yes, I could have bunched them all into one step because they have the same reason. So same side interior angles are supplementary. All right? Okay. Now why is 1 congruent to 3? This is why it's going to get tough on you guys. Because not only am I using angles from this unit we're currently in, now I'm going to use the theorem we did in unit 2. Read steps 2 and 3 again. 3 is supplementary to 2, and 1 is supplementary to 2. We had a theorem out there that said, oh, that must mean 1 and 3 are congruent. This is why it's going to get tough, and you got to bring these up on your own now, right? Whew, well, go ahead. You think you got it, Audrey?
Supplements of the same angle are congruent.
There we go. Guys, take a look. 1 and 3 are both supplementary to the same angle. Angle 2. So according to our theorem from last unit, supplements of the same angle are congruent. Ooh, it's getting tougher now. You see how we're just, the 2 units are weaving together here, and they'll never go away. Any issues there? Because 1 doesn't make you great. Go ahead, Radhika, and then Sophia. Go ahead, Radhika.
Could you use substitution or no?
Ooh, so you don't. What are you substituting in though?
You're substituting 1 for 2 and wait, never mind.
You get 1's got to be equal to 2 if I'm going to substitute it in, right? Okay, Sophia, then Hannah. Sophia, go ahead.
I'm assuming you have to write out the full word supplements. You can't if you shorten it to sub.
So SUPP in here is short for supplementary.
Oh, okay.
Okay, Hannah.
So I know in the video you said that like sometimes you consecutive. So
That I didn't mention that when I did the review at the beginning, but if you don't want to use same side consecutive or consecutive interior angles, that's fine.
Okay.
Yep. Do not do some of you guys just call them interior angles. No good. Same side or consecutive, please. Good question, Hannah. Are we all good? 1 doesn't make you great, and on the next one, I didn't provide the statements for you. All right, so go ahead and get it written down. We got work to do here. Mark your diagram. You guys know the deal. Start looking at the proof statement. Look at the angles in the proof statement. Hi, Sophia.
The page is 89, how much did you over the weekend?
All right, let's talk. Everyone's got your parallel lines marked and the congruent angles marked with arc marks, hopefully. Please take a look at the angles I'm trying to prove congruent. Everyone, make sure you know where they are. Okay, CDF, everyone see that one? It's a little bit bigger. And DFE, which is also a little bit bigger than the given angle. Okay. Woo! Anything I give you is for a reason to use it. I promise you, I will never give you a proof where there's one given you never use. Promise you that. You will use every single given. So let's start. Why did they give us that the lines were parallel? To look for a special angle that may help you. All right, so do you see any corresponding alternate interior, same side interior, formed by AD and BF? Don't give me angles that are formed by CD and FE. Give me angles that are formed by AD and BF that have a relationship because they're parallel. Do you see any of those types of angles in that diagram right now? Anybody see any corresponding alternate interior, same side, that are formed by AD and BF here? Do we see any? Quincy, what do you see?
ADF and BFD are alternate interiors.
Everyone see the angles he's talking about here? Right here, ADF and DFB. Everyone see those angles right there? Alternate interior. Do you see why they're alternate interior? And I hate to do this, especially in an honors class, because it sounds so elementary schoolish of me. But if you ever want to look for alternate interior angles, look for the letter Z. Anybody see the Z? And the alternate interior angles is what the Z eats up. Very elementary schoolish, but if it helps you find alternate interior angles, so be it. Okay. All right. So yes, Quincy, good work. So I know angle ADF is congruent to angle DFB. Okay. What's my reason going to be? Keep going. What did I give you? What do you start out with? What type of lines? Ready? Parallel lines imply. Now what type of angles do I have? Alternate interior angles are congruent. The reason's never going to change. It's just what type of angles. Okay, so that's why they gave you the parallel lines. Anybody know why they gave us the other set of congruent angles? What do they want us to do to get to the bigger angles? This is addition. It's not going anywhere. Okay, it's addition. Everyone see? Add up the two angles, you get the bigger one. Add up these two, you get DFE. So somebody tell me what the addition's going to look like here. Oh, again, Ellie, go ahead. You're on fire today. Last one for you today, Ellie.
Angle CDA.
And yep, hold on. Angle CDA. What are you going to add to it?
ADF.
Good job. ADF. And we'll say that's equal to, go down now, angle
DFE.
DFB. Got it. Plus
BFE.
BFE. Perfect. And that is addition. And guess what else isn't going to change? Guess what the next step's going to be? I just wrote addition, so it's got to be what? Substituting in the equals now. So angle CDF is congruent to angle DFE. Substitution. Okay. Whew. Don't get buried. So look at your givens. Why did they give us the lines were parallel? So we could see the alternate interior angles. Why did they give us a pair of congruent angles? So you could add them together. All right. Questions there before we get to the big dog? Total beast mode before we go into the weekend here on this last one. Let's go. Don't hide from it. Accept the challenge. Ooh, anybody reading the givens and maybe a light's going off in your head right now after you read the givens? Ooh, I've seen this before. I think I know what's going to be in the proof somewhere. I got some parallel lines. Come on now. Come on. We got this. All right, we ready to go here? Woo! We're going to finish this on a strong note here. We got 5 minutes to finish this up. We can do it. All right away. Givens. Anybody want to talk about what you see in the Givens from last unit that automatically signals, hey, I'm probably going to use this, Sophia?
Bisect.
Okay, how many angles are getting bisect? 2. So you know what's got to come up eventually is what? Anybody at home? What's got to come up eventually if I see 2 angles are getting bisected? Halves of equal quantities, right? Halves of equal quantities somewhere, probably at the end. But for now, before I get there, don't you usually have to tell me what you're taking half of? All right? If you're going to use halves of equal quantities, you need to write down what's being cut in half. So somebody give me 1 angle that's being cut in half. 2, here we go. Quincy.
Angle JEB.
Okay, so I'm going to say half of JEB equals, well, if I take half of JEB, I get JEF and I get FEB. I only care about one in the proof. Out of those 2 angles, JEF and FEB, which one do I care about?
FEB.
How did Quincy know that? Because FEB is one of the angles I need to prove. What's another angle I need to take half of? Yeah. Maeve, come on, Maeve. What's another angle I got to take half of? Darn right I do. And if I got to take half of EGD, Maeve, that could be EGH or it could be HGD. Which one do I want? Good job. Do we know why? Do you know what gives me the right to take half those angles? Not halves of equal quantities. We're not there yet. What gives me the right to take half of those? You knew you were going to take half of something. Why? Lucas, what told me I need to take half? Oh, he is.
Half of equal quantity, or are you talking about the bisect?
There we go. Definition of bisects. But guys, I know usually step 3 would be the proof statement halves of equal quantities, but no. Isn't there a given I haven't even used yet? What given I haven't used yet? What's the one given up here I have not used? The parallel line. So they gave me parallel lines for a reason, and here's why. Everyone agrees we're going to use halves of equal quantities. We're all in agreement on that, correct? Say the theorem with me right now. Halves of quantity. 2 more times. Halves of, and 1 more time. Halves of. So what you're taking half of better be what? Equal. And usually in unit 2, I just threw that in the given. You didn't have to worry about it. But did I tell you these 2 were equal yet? No, but look at the darn diagram and tell me why they're equal. Why are JEB and EGD, the 2 angles I'm taking half of, why are they equal? And this is why you needed to know the lines were parallel. Yeah, let's go, Hayden. Why are those 2 angles equal?
They're corresponding.
Darn right, they're corresponding. So that's got to be my step 3. And then my step 4 can be halves of equal quantities. So JEB is congruent to EGD. What type of angles, Hayden?
Corresponding.
Parallel lines imply corresponding. Angles are congruent. Okay, guys, you need the halves to be equal. Go ahead, Quincy.
Since those are kind of unrelated, the number 2 and number 3, does it matter what order we do it in?
No, it does not. Good question. You could have the parallel lines one first. Or number 2. That's fine. Does not matter the order. And you guys are going to see, you do a proof and your buddy does a proof, and it may be out of order, but both are correct. Okay, everybody good? Do not give up. My version of the proofs are up on Classroom. Okay? But yours may still be correct, so bring them and let's check them on Monday. Don't give up. It's getting tough. Don't give up. This is what separates honors from regular here. Okay, you guys at home, have a good weekend. Don't give up. Hand in your assignment by 1 o'clock. Check Aspen for your test grades at the end of the day.
Oh my
There you
God,
go.
I
That
forgot
was
the
a
last of the
session.
week today.
I'm literally like,